Hi folks, I'm Dave.
And I'm Ben.
And you really must be getting tired of us by now.
What are you still doing here?
However, thank you for coming back, and we're excited to get to today's video because we're going to do something a little bit more sort of visual today. So far we have looked at the applications of the concepts that we've been introducing you to, and they've mainly been sort of used in a text sort of context. You know, we're making text appear on the screen. Context, which actually means with text, because con is Spanish for with, isn't it?
I've got no clue.
It is. I can tell you that now. I hope I'm right on that. I'm reasonably
I really want it
confident.
to not be.
No, I'm pretty sure it is because
Okay.
it's with text. Anyway, we're already off topic. So while I'm just chatting here for a second, Ben is going to load up the project that we are going to have by the end of this tutorial. And we will be covering all the mechanics involved in this project. And as you can see, it looks pretty cool with some color changing stuff and basically bouncing a ball or a shape around the screen. Now, the whole point of today's video is to explain to you how the screen works so that when you're writing your own project, you don't feel sort of intimidated in just getting anything on the screen and moving it around. Hopefully, if you don't know how the screen works, this video will sort of, pull the wool from your eyes and enlighten you, and the heavens will open up and light will shine down and it'll be brilliant. So
I learn an awful lot of idioms from these videos.
Try and maximise.
Your eyes. I've not heard that one before.
Have you never heard "pull the wool from your eyes"?
But we're getting distracted again.
I like my idioms and my puns. So yeah, you will be subject to those over the course of all these tutorials. Right, Ben, let's get rid of that because we don't want to get them too excited for the end result here. Load up that project that we made earlier on called Coordinates. So if you don't know, the screen, and this goes for pretty much every modern type of screen, with the exception of old, they're called CRT TVs, like a cathode ray tube. And a lot of people in the audience will know exactly what I'm talking about. Maybe if you're a little bit younger, you won't know about these sorts of TVs. They work very, very differently. They're really huge and really heavy. But modern TVs, they work in this way. Now, in FUZE, you access the screen with coordinates, and that is often the case in pretty much all programming languages. You have essentially what are two number lines. You can think of it like two big long rulers, and they measure pixels. Now, if you're not sure what a pixel is, I would look it up because there's some awesome videos on YouTube of people like zooming into screens and seeing all the things that make up pixels. It is really, really cool. There's one where you can see Mario being played on a hyper zoomed in level. It's really strange to actually see it at that sort of detailed level. But no, you can actually see pixels if you get close enough to your screen. But disclaimer, don't go bashing your head into your screen. Don't sort of put it on the edge of your table and then knock it off the edge of the table. But you can kind of see them. They are tiny little square lights. And each one is made up of three smaller lights, a red, a green, and a blue. And we make any color of light by mixing these three different colors together in different ways. And that's how we get, just every different color under the rainbow. Under the sun, in the rainbow, under the sun. There's another idiom for you straight away. And that is how we generate all of these different colors on the screen. Now, what Ben is doing is he's moving this circle around the screen, and you see that central black dot on the circle? That is the point which X and Y are describing. So the numbers that you're seeing there on screen are the coordinates for the X and Y position of that black dot. Now, we're using a big white circle to show this, but when you're putting a circle on screen, the actual X and Y position of that circle is the exact center. This is different with different shapes. Circles work in a particular way mathematically. So when you are actually drawing a circle with code from scratch, you only need to know the central point and what's called the radius, which is the distance from the central point to the edge of the circle. And if you know those two things, then you can draw a circle. Squares and triangles are a little bit different, and we'll probably get to those in future videos. We'll be using all different shapes for the tutorials coming up, but you can also check all of these commands and functions out in the FUZE help documentation. If you just actually type in the name of a function, so if you type in circle, and then you click on the help button on the on-screen keyboard, it will open the help at that function's help page, which is really, really helpful for reminding yourself of the layout of information in a function. But I'm now getting completely off topic again here, but it is important to mention. So as you can see, as Ben moves the circle over this way, which would be so this way, the X coordinate number is increasing. So kind of disregard the Y coordinate for a second, because it's very, very difficult, almost impossible, to move the joystick along just one axis. Because I mean, these joysticks are incredibly sensitive, and as you're moving it across the X-axis of the joystick, you're very, very likely to be messing with the Y-axis as well. So just talking about the X for now, you can see that as Ben is moving that around, that number is going up as the circle moves this way and down as it goes towards this way. Now, we have a number line then from 0, which is over here, to a number. Now, this number depends on what screen you are using. If you are using your Switch in handheld mode, so you've got it out of the dock, there are 1,280 pixels along this x-axis. If your Switch is in a dock and it is being used in TV mode, then you actually have 1,980 pixels along that x-axis. And because of that difference, you will find that your programs might look different. If you're running them on your handheld mode and then you put it into the dock, you might notice that everything's gone out of place. And that's because all the coordinates that you've used have suddenly changed, because the screen dimensions have also changed. So I believe we're in 1920 here, not the year, but the resolution, because our Switch that we're using is currently docked and in TV mode. No, actually, no, we're in 1537. So, okay, we're rapidly moving toward the future as Ben goes across there. Right, so that gets us to understand the x-axis. We're going increasing along the x-axis as we move from this direction towards this direction. So the y-axis is exactly the same, only it's a tiny bit weird to get your head around depending on what your foundation is. So the way that Fuze4 Nintendo Switch works is that the 0 on the y-axis is up top. And in some programming languages, this is different. You might have it, actually in the old version of Fuze, 0 on the y-axis was at the bottom of the screen, but we made a change because it's actually more conventional. There are more programming languages, more professional sort of standard programming languages, which use the y-axis in this way around that it is now, with 0 being at the top and the maximum number being at the bottom. This is sort of more common nowadays, but it only takes sort of a little bit of practice before you are thinking about this in a second nature sort of way. It really isn't too long before you'll just understand it intuitively. It might feel a bit strange at first, but stick with it. So as you can see, Ben, if you're moving that up and down, we are increasing our Y position as Ben moves the stick down. And this does bring with it some complications when you're using the controls, which we will get to in later videos. Only minor complications, just basically flipping a few numbers around. But this should give you an idea of what's actually happening internally when things are moving around the screen. Any time you see anything moving on a screen, you can think about it in this way, even if this is 3D and not 2D. Because when you're using 3D, it's the exact same concept, except you have another axis. So instead of just having X and Y, you also have Z. So you've got this 3D axis. But the concept is exactly the same. You are only ever either increasing or decreasing your position on one of these axes. Okay? So with that in mind, what we will do...
One more thing I want to mention.
Yeah, go for it, Ben.
You can go off the screen. So if let's say you put minus 145 as your X value, it won't just not do anything.
Yes.
It will put it into existence, for lack of a better word.
No, that's quite right. That is quite right. Just because you've put... Yeah.
You won't see it.
You won't see it. Just because you've put a minus position, Fuze isn't going to say, well, that's off screen, so I'm not going to bother drawing that. It will still draw it. It's just that it's not within the confines of the screen, so we can't see it. But it is still there. It's still being processed Fuze is still actually having to do some work to make that happen. And you will see this sort of thing in the Fuze demos. When things go off screen, we tend to either like remove them or stop them from being drawn or processed just to save on power, really, save on computing power.
And the same goes for at the length
opposite end of the scale.
Yeah,
I mean, it's maybe our program isn't too fantastic because we wanted to make sure that the X and Y coordinates were nice and clear and in big font like this, but because they are in that particular place, they kind of vanish. But you can get the idea. When that coordinate becomes too big, you know, it's still exactly the same as it is on the other side when it's a minus number. If it's bigger than the actual screen confines, then it is still being drawn. You just won't see it. So being aware of what your screen dimensions are at every point in a program is really, really helpful. And this should hopefully give you a bit more context when you're looking at the Fuze demo programs. You will often see a line of code that says something like screen at the start of the loop. I know that I use this technique a lot where every single time we're going around our loop, on every frame of our program, I'm reading what the dimensions of the screen are. So is it being docked or is it not docked? Is it in TV mode or is it in handheld mode? And then you can change all your coordinates accordingly so that you won't get this strange changing of places. But this is getting a little bit advanced and it will be something that we will address in later tutorials. But Ben, let's actually get into some coding. Should we start a new project? If we start a new project, our goal is just to get a circle on the screen and then make it move. And this will... I thought you were going to type in circle of life there. This will actually tie together all of the things that we've been learning so far, except arrays. We won't be using arrays in this project, but it will use a loop, it will use variables and if statements to great effect to make a really simple project. Not the eye contact again. It's eerie how accurate you are with that, Ben. Makes me think that you must practice that in your own spare time, maybe with a mirror. Maintaining eye contact. No, I'm creeped out. I'm fully creeped out, for the record. Now, I was going to say something just then, and it has completely slipped my mind, so I'm just going to let that go, and I imagine it will come back to me at some point in the day. I'll just sort of blurt it out if I suddenly remember. Right, so we've got a nice blank editor there. And as we said, the first order of business is just to get a circle on the screen. Now, circles have a bunch of different properties. They need an X position, they need a Y position, they need a radius, so kind of like the size, the distance from the middle to the edge. And they need a number of sides, which is a bit of a weird one, and you should be questioning that, because if you know your basic shapes, then you will know that circles have one side, and that's just how it is. Well, in a screen, you know, it's not actually as seamless as a pencil, just drawing one seamless line. You actually always have a number of sides because it can only ever be, you know, one pixel at a time. So you kind of, you always have a step sort of blocky circle. If you zoomed in close enough, everything is like that. There are no smooth lines on a screen. But in Fuze, there's a cool feature with circles where you can actually give it, I don't know, 3 sides and get a triangle instead, or 5 sides and get a pentagon. And you'll see some of this in the demo projects as well. So Ben, you're just setting up some basic variables here, yeah?
Yeah.
So we've got an X variable and a Y variable. These are going to store our X and Y positions for our circle. And you will need to use variables for this project. You don't need to use variables if you just want the circle to just be in a place, because it's just always going to be in that place. If you said, in fact, actually, Ben, could you just type this out for me? Circle, and then in the brackets, if you put, what was that?
Function brackets.
In the functions brackets, yes. If you put, I don't know, just do 10, 10 actually. And then what is it after that? Radius. So radius. if we do 50 or 100 or something, and then number of sides. If we have 32, that's going to give us a nice smooth circle. And what is it next? Color. Yes. I'll let you choose the color while I have a quick sip of water. Let's not use random then, because it's going to be flashing all over the place. Yeah, I think it might be a bit of it might be a little bit much on the screen there. Let's just stick to it. How about yellow? something bright. Ruse. Fuse pink. It's always a safe bet. You didn't want to go with yellow like the sun. Okay, fair enough. My ideas aren't good enough. I'll take my business elsewhere.
Okay.
And for the for the outline, yeah, we can put false. So you can put 0 or false interchangeably, or 1 or true. They're both the exact same thing. Yeah, let's stick to being super correct, and we'll put false in the brackets there. So this circle is only ever going to be in one place on the screen. Its X and Y position is 10. In fact, actually, it's kind of off screen. Let's add a 0 to both of those. We'll put it at 100, 100. So then when we run this, it is putting this circle here every single time it goes around the loop. But it's always in the same place. It's always in 100, 100. 100 on the X, 100 on the Y. So it's always there. It's never going to move. And if you want something to move, you have to use variables, because you want those positions to change during the program. And we can't change the value of 100. It's always 100. But if 100 is stored in a variable, we can change it. So let's now replace our circle position parameters with our variables, X and Y. And for now, it's going to be exactly the same. Ben, could you also add a clear to that loop as well, just above? So I want to structure this video kind of in the same way as the screen tutorial in the actual Fuse tutorials, where we delete clear at the last minute, and I shouldn't really give it away. Okay, so we're exactly the same, nice and neat though now with variables. So if we want this circle to move, if we want it to move, we need to change or manipulate the value of one of these variables. Let's start with the x-axis. We're going to use our good old friends plus equals and minus equals here. So if we do x plus equals and then a number, Ben, I'll leave that one up to you. Whatever number you want. 3, what a number. It's the magic number. It is actually the magic number. So this is going to be moving at 3 pixels per frame, yeah?
Yeah.
So on the first frame, actually it's not going to be at first, is it? Because we are going to add this first. So we're actually adding 3 straight away to our x position. So the circle will appear initially at an x position of 103. Then we are going to clear the screen, so get rid of it. And then we are going to put the circle back there at a position of 106. And then we're going to get rid of it. And then 109, we'll get rid of it. And 112, and I'm not going to go any further than that. So we're moving at 3 pixels per frame. And this will give us this movement effect. So if you run it nice and slowly, off it goes. See you later, circle. So that's about it. There's your game. That's all you're getting.
And it's gone.
And it's gone.
So
that's the end.
Hope you enjoyed it.
Yeah, it was very short but sweet, very informative. Bye. No. We've already said where we're going to get to with the finale. We just can't leave it there. Let's go back. Okay. What is the next order of business, Ben? We've got a circle moving this way. I think before we worry about the y-axis, if we just get this circle bouncing between the x-axis boundaries of the screen, that will. I think it'll be a bit less complicated, and then we can do the exact same thing we've already done, but for y, and that'll be nice and simple. So we need to sort of understand something that's happening here. That 3 number is not just. It's not just the speed. I mean, it is the speed. It's the speed that circle is moving every single frame. But more than that, it's a direction. Because as we saw before in our little blue background circle moving example, when we are moving this way, we are decreasing the value of x. When we're moving this way, we're increasing the value of x, and then vice versa for the y-axis. If you're adding a positive number, then you are moving in this direction. And if you add a negative number, then you'll be moving in that direction. Now, you could just do minus equals, but that will lead to some complications a little bit further down the line. And really, you can do a lot of fancy stuff by just switching between positive and negative numbers all over the place in your code. In fact, I always see really, really simple things like just using positive and negative numbers in a new context that will usually be Luke, who's doing some wizardry on something, and I'll just think, I would never have thought of that. It's one of those awesome things. But hopefully, through being exposed to these little applications of using these concepts, you can start to think for yourself, I'm going to try this and just see what happens. So, as Ben, did you just demonstrate that? Did you put the negative?
Yeah,
I wasn't watching.
Yeah.
Yeah, great. Awesome, yeah. So then it's going to be moving that way. So if we want the circle to bounce, what's actually happening is that we are changing the direction. We just need to say, if the circle gets to a particular point on screen, change that direction. So as soon as you want something to change, you know it needs to be a variable. So instead of 3, let's have a variable called xdir, for, I don't know, or dx or something like that. Yeah, that's nice and simple, x direction. And then we need to make that variable in our global variables there, and we'll make that 3, or whatever you want it to be then. Now, guys, feel free to obviously put whatever numbers you want in these variables if you are going along with this project. Usually when we're doing these workshops, the first thing somebody will do is just be like, 1,000. I have to do that. You've already written it. I have to do 1,000. Now, bear in mind, if you do put in these massive numbers, you probably won't even see the circle, because as soon as you move 1,000 pixels across, you're basically off screen. So don't expect it to behave exactly in the way that you might predict when you're using humongous numbers. Same goes for the size of the circle. If you put 1,000 in the size of your circle, then it will fill the entire screen, and it will not move at all, because you're moving a 2,000 diameter circle. 2,000 pixel diameter circle. So yeah, 1,000 pixel radius circle, 2,000 diameter. I did adopt that correction, I think. But thank you for paying attention, Ben. If you're moving a gigantic circle that is bigger than the screen at 3 pixels per frame, you're never going to see it move. It's just going to be a coloured screen, which might be what you want, but there are easier ways of doing that. Anyway, by all means, do try those crazy numbers. It is how we all learn at the end of the day. So we've got our direction stored in a variable, and we are now adding that instead of just a fixed number. So now what we need to do is use an if statement to check the position of the circle, and if it has gone too far or it's gone too low, let's just stick to too far to begin with. We need to flip our direction. So if x is greater than, now this is where we are going to introduce a really, really helpful function. And as soon as you know these functions, you're going to be using them all over the place. They are called g-width and g-height. Now, g-width is what we'll start with. Ben, if you just add that there, yeah, if x is greater than g-width. Awesome. Now, g-width basically just returns however many pixels are on the width of the screen. So if you're in handheld mode, that number will be 1,280. However, if you're in TV mode, that number will be 1,980. No, I've forgotten it now. 1080 by
might be sometimes.
1920. 1,920. Beg your pardon. So yeah, I'll say that again just to make it clear. If you're in handheld mode, g-width is the number 1,280. If you are in TV mode, g-width is the number 1,920. But you can also use the set mode function to make the screen resolution whatever you want. And then g-width will be that, and it will reflect what you have set it as. So it's actually more useful than just using the fixed number. If you use g-width and g-height in your programs, when you remove the switch from the dock or put it into the dock, everything should, with a couple of exceptions, sort of figure itself out. Because every single frame you're reading the width of the screen and you're changing things based on that. So anyway, if x is greater than g-width, then now we will run into a bit of a problem here, but I want to see the mistake first before we fix it.
Yeah.
I think you're on the same wavelength there, Ben. So we're going to take xdir, and what are we going to do to it?
We're going to make it negative.
We're going to make it negative, because as you saw before, when we have a negative number and we're adding that, we're just taking away. So xdir equals minus xdir. So xdir is 4. As soon as x becomes greater than the width of the screen, it becomes negative, and now we are adding minus 4, and we're moving this way. See if you can predict the problem that we are going to have. Because this is a really, if you can predict it, then that means that you are following along exactly here, and you really are seeing exactly what we're doing. Don't worry if you can't predict it, because it's really not an obvious thing. But we did give the information away at the start. Remember which point on the circle is the X and Y position describing? That really is the key issue here.
And I can think of another one that might be a problem, which we might as well add if X is less than 0.
In fact, the cool thing is, though, Ben, we don't even need a separate if for that.
Yeah, no, we don't.
Because if you have a negative number and you make that negative number negative again, you're just making it positive. So -3, if I said take the number -3 and make it -3, we're now just in the positive realm and it's just 3. So we can actually just add an or to this if statement. So we're saying if X goes over here or X is less than this point, then just flip the direction. Just make it the opposite of itself. It's either negative or positive version of itself.
Yeah, so when we did the video on if statements, we talked about if something is true or if it's false. And what or means is basically if this or this, if there's a true statement inside of or before then and after if.
I mean, think of it like if is just sort of the opening to your line here, and then what follows is the condition. In fact, actually, so some programming languages, in fact, most of the advanced programming languages, will use brackets around that part of the if statement. And you can do this in Fuse as well. It really will not mind if you do it. And sometimes you actually need to do it because brackets do make things happen first. So if you had a massive complicated if statement that, you know, had all these different things being checked, you could say if, in brackets, this and this, or this and this, or this and this and this, or this. And you can put brackets around any part of these conditions to make them happen in certain priorities. So Ben, could you just add that actually? If you just put brackets around the condition itself. And so this is the part which you can think of as being either true or false. We're saying if this thing here is true, is X greater than G width? Well, if it's not, that is not true. But then you have another condition. I don't think you wanted there. No. I think you want it, before the then.
Sorry.
That's all right then. Perfect. So now you can really see visually our actual conditions. Is this true or is this true? If either of those are true, then we flip XDIR. And that is how that if statement is working. That's a really good point, Ben. Thank you for pointing that out. Okay, so should we run this program, see if it gives us what we are hoping for? And we should get a nice idea of what this problem is going to be. So we maybe should have made it go backwards first, but we're getting there now. So here we go. Let's see what the problem is. Has it happened? Right. Did you see that by any chance? Hopefully you noticed it. I was looking at it, Ben. It's right there. No, it's not. It's there. And it happened again. Did you see that? Ben, how did you not see that?
I saw it that time.
Okay, good. So in case you didn't see, what is happening is, there you go. The circle is moving halfway off the edge of the screen boundary before it changes direction. And if you remember, the middle of the circle is the point described by our XY coordinate. So when we say if X is greater than G width, well, that's no good, because as soon as X is greater than G width, half the circle is already off the screen, because the middle of the circle has hit the edge, but already half the circle's gone. So we need to modify our condition here. And there's a couple of ways that you can do it, but there's a really nice and easy, and thankfully it's a circle. This is kind of why we use the circle here, because it makes this part very, very easy. As I've already said, the property of a circle called the radius, which is the distance from the middle to the side, to each edge, at any direction, is what we're going to use. It's really, really helpful. It's the exact half measurement of the circle. So there it is, 50. So there are 50 pixels from the middle of the circle to the very edge in any direction. So depending on which way the ball is going and which one we need to check, this is going to change slightly our modification here. Ben, if you could, on that first condition there, if X is greater than G width. So it's not if X is greater than G width, it's if X plus the radius is greater than G width.
Should we make the radius a variable as well?
Let's make the radius a variable. I thought it already was. Rad? That is rad, Ben.
You need to stop that.
Look, I can't help these absolutely radical jokes. Okay, so if X plus the radius, and you can think of that as the right-hand side of the circle. The right-hand side of the circle. So if it's X, have you already added the? Have you added the other one? So on this side, because we're talking about the 0 side of the screen, X plus the radius is the wrong side to go for. We need X minus the radius. So think of that as left side, right side. Yeah, that should do us. So if X plus rad is greater than G width, or X minus the radius is greater than 0, if the right hand side of the circle is greater than this part of the screen, or if the left hand side of the circle is less than this part of the screen, then we need to flip the direction. This should be pixel perfect collision with the walls, if you like. And we're going to have to wait. We like to ramp up the tension, you see. There you go. That's nicer. Now, actually, on our screen, it doesn't look so good because we have a slight border around our monitor, so we actually can't tell if that's right or not. Hopefully for you guys, that looks really pristine. Ah, yes, okay, yeah. Change the background colour. Fuse blue. It's going to be quite bright. Ooh. Do you know what that reminds me of? A Postman Pat book that I used to have when I was like 6. It had this blue cover, and the writing on it that said Postman Pat was like bright red. And if you sort of wobbled the book around, it looked like all the letters were jumbling about because of how weird the contrast was. That is what that instantly reminds me of. Not even Fuse, which it should remind me of Fuse because it's Fuse blue, Fuse pink.
I was thinking that when you said,
you know what that reminds me of? Postman
Fuse.
Pat.
No, I was thinking you're going to say Fuse. It's like
no, yeah. No, you definitely thought I was going to say Postman Pat. I mean, who wouldn't say that? Then it's obvious, man. Come on. Okay, moving swiftly on. We've got a ball bouncing along the x-axis. That's all well and good. But now, as we said, we can just really quickly adapt this for the y-axis. So Ben, if you just copy all the stuff. Oh yeah, we'll need another direction variable because if we use the x direction on the y-axis, then things are going to be very unhappy when one of them flips. The ball will just sort of be moving around the screen all weirdly in a way that makes no sense. So you can use copy and paste here. Really, really nice and simple. And I mean, I'm so glad that feature exists. However, there will be one extra change that we will have to make to this one. And I think Ben has just skipped over it, which I'm actually quite glad about. Has he seen it? Has he seen it?
I think I've seen it, yeah.
You've got it. So, of course, G width and G height are not the same. The height of the screen is in handheld mode 720 pixels, in TV mode 1080 pixels. So if we use G width here, then the ball will go off screen before it bounces. So we actually want to change that to G height. And that should, famous last words, be all we need here. Shall we, tell you what, let's increase our speed variables, so the X and Y direction variables. In fact, if you wanted to make this a little bit easier to edit, you could make a speed variable just above, and then just put that variable into both of these variables. So you'd say speed equals 5, xdir equals speed, ydir equals speed. Then it means you can't have two different numbers, yeah. Unless you did like xdir equals speed, ydir equals speed times 2 or something. You could modify it that way. But then you're just kind of making it more complicated. So maybe just stick to this method. Let's see what that looks like. So that's twice as fast. So it should be bouncing off the up and oof. I think hopefully when I said
it's
that.
It's behind us, Dave.
Oh yeah, sorry, yeah, we're on a different. No, but it's a cylinder that comes out like this. You know? So so silly.
We're in front of it though.
Yeah, but it's a big I mean I can't anymore, Ben. It's melting my brain. Okay. You know what I want to do? I'll tell you what I want to do here. I want to make that circle bigger. It's not big enough. Let's make it bigger. What are we going to change?
Rad.
We'll change the rad. We'll change the radicalness of the ball. Let's make it twice as big. Put it as 100. Let's see what we get. That's a bit better. Okay, so we've got it bouncing around the screen. So that's all well and good. This, you might recognise, is very, very similar to a classic and very famous game known as Pong. Now, obviously, it's not Pong. There is a lot of more stuff that you would need. Potentially, well, if you were going to adapt this program into a game like Pong, there's no reason to just stop at the basics. You could add whatever you wanted to it. Make it have 3 balls going around at the screen at once. Don't just settle for the least complicated. You should try and make things as weird and as wacky as possible. But it really isn't much to add to actually have a working version of Pong here. You would just need 2 rectangles, one that's controlled by one joystick, one controlled by the other, and you are pretty much there. You would just need slightly more complicated if statements to make it bounce. There are actually some examples of this in the FUZE example programs, and in the next tutorial, I don't want to speak too soon there, but I believe in the next tutorial we are going to look at actually accessing the Joy-Con controllers and using those in your program to do something like this, except move it around with the Joy-Cons. Because it's really, really useful, and as soon as you know how to do that, it really opens up a bunch of stuff. But back to this project. First of all, then, I want to reveal what I wanted to do earlier on. If we go back to the code, if you just comment out that clear line, this makes it very clear what is actually happening on each iteration of the loop. So I'm not sure if you know what I mean, but you may have used one of those flick books before, where you've got like 50 different sheets of paper and each one has a stick man on it in a slightly different frame of movement, and then you go like that and it's moving around and it looks really, really amazing. And you might have even made them. You can make them really easy. They are a lot of fun to use. I really like them.
I've tried to make them. They look appalling. Because you'll just have one frame where it's like that, and then the next one is like that.
He's flowing forwards a lot.
Yeah,
do you know what? I got a couple of those flip books, I believe from like a Christmas stocking or something, and it was really cool. One of them had like a little bug that ate the pages. And so it actually made holes in the pages as you flick through. It was really cool. It's like
cool.
taking it to like a totally new level, these flip books. I was like, oh my God, I never even knew this could really even exist. It was just amazing. Okay, so you've put the clear at the start. In fact, I believe that will still be black when we run it. In fact, we might get like one frame of blue, but then no, it should be just straight blue. Actually, could you run that for me, Ben? What am I talking about?
I've got no idea.
What an embarrassment. But you can see what's happening here. So just to go back to that flipbook analogy, what we've just done is essentially made all the pages of the flipbook totally see-through. So you can see every single stage of movement that came before it. Because really, you are not seeing the same ball. When that ball moves, it's a new ball. We've gotten rid of the old one. We've made a new one in a new position on the next repetition of the loop, and now that is where it is. So you can now see the whole path that the ball has taken up till now. Now, it's not very exciting because it's just in one colour, so it's just a big fuse pink V, basically, in the middle of the screen, which is all, it's all well and good. It's kind of a bit dull. So if we've got some...
Like a love heart, actually. It's got like the
curve
on it.
It has got a bit of a curve on it, but it's also got sort of bumps along all the different sides, which reminds me of like a... Well, I don't even know what that reminds me of, actually. But it's getting a bit hypnotic, and we should stop looking at it. Whew. Where were we?
Are you right?
I think I'm okay.
Okay.
I might need a minute.
Right.
Okay. All right. I know I can do this. Okay. Rid of the hypnosis. Right. So we can do a few things here to make things really instantly quite cool. For a start, Ben, if you change that false in the circle line to true...
What does false actually mean, Dave? Because I don't think we covered that earlier.
We haven't even mentioned it once. I like to be mysterious and cryptic, you see. No, it's a brilliant point, Ben. So the last argument or parameter in the circle function is whether or not you want outline mode enabled. So if you say true here, you want outline mode enabled, and it will just draw the outline of the circle. Putting false gives you a full filled-in shape. This also works for the box function and the triangle function as well to give you these different shapes. But as you can see, this really adds a lot of visual interest to the program because it kind of looks like an infinite slinky that's very angular. I tell you, I love the patterns that it makes when it like overlaps itself, like in the corners there. You can really see some interesting like geometry happening. I mean, I love programs like this, ones that don't really do anything all that impressive in terms of the mechanics of it. They just make something very interesting happen on the screen visually. And I could sort of sit there and just stare at that for ages. It's a lot of fun.
Let's do that.
Let's just do that. Okay, let's return back to the video before people get annoyed that we're just being silent. You should all pause the video and stare at it for as long as you feel comfortable for a minimum of 6 hours. No, don't do that. Do not do that. Okay, so we've made our circle hollow. Now, if we were to start changing the colours of that circle, then that will really have a big effect when it is. Actually, to be honest, whether it's filled in or hollow, it's still going to look really cool when you start changing the colours around. And I think that to do this, then we should. Let's go to our other project. I think it's about time now that we opened our other project, because there's a whole section of color changing code in this finale.
Okay, that's the
and
one.
This is actually just taken straight out of the end of the screen tutorial in the FUZE projects. So if you do like the look of this, don't worry, you do not need to pause the video or anything. You can just go and take it from the FUZE project, copy it into a new program, and there you go. And as you can see, we're not using a circle anymore. Well, we technically are, because that is what the function is being, that's being used is. It's right there on screen, circle. But you can see that we've got variables there for everything in our circle line. And at the top of the program, we have got the actual definition of those variables. And in the sides variable, we're saying 6 sides. So that is not a circle, it's a hexagon. And but it is kind of still a circle. So wrap your heads around that one. If we change that number, Ben, put just a 3 for now. And we'll have a triangle. So you can actually get a lot of stuff to happen. It's very, very interesting visually if you start changing that, especially if maybe you made the sides change over time. Maybe you could make it so that when it hits one of the sides, instead of just changing direction, you change the number of sides. You could multiply them when it hits one side, or you could take them off when it hits another side. You could make a really cool looking project. However, bear in mind, if you put 0 sides, you ain't going to get anything. And if you put 1 side, actually, or is it 2? If you put 2 sides, Ben, for me, then it'll just be a line, yeah. So that's really cool as well.
I do like that.
I really like that. Yeah, I like that. You know what that reminds? You know what? I'm saying too many things that things remind me of today. But I think there's like an old BBC sort of startup screen that gives me sort of similar vibes to this. It reminds me of old TV, old like teletext TV. He wouldn't know, Although I'm too young. These young whippersnappers and all their fancy YouTubes. Back in my... No, I won't. Right, so I would like to just go over a little bit of this code, because it would be, just cool to give you an idea of what's happening. You do also have comments there copied in from the FUZE demo, which tell you what all the different sections of code are doing. You've got X speed and Y speed, which are just our X and Y dir variables from before. You've got the color variables here. Now, the cool part about this, and we will go into this in subsequent videos, you are seeing a vector right there. And what you're looking at actually is a vector for the color red, because it's got a maximum value of 1 in any of these channels, and it's got maximum red, 0 green, 0 blue, and it's fully opaque, so not see-through. You can really see it.
So you might have heard RGB, or red, green, blue, before, when talking about colours on screens, and that's just what these are.
Exactly.
And going back to pixels, if you look it up, these are the 3 colours. I'm not sure if you mentioned that they were the 3 colours.
I did, yeah. I was just going to say, you've brought it back to... Yeah. It's really cool, because... So they are the sub-pixels within each pixel. You've got 3 little tiny pixels, and changing the balance of those colours makes any colour. And that's exactly what's happening here. Now, we've then got this quite fancy if statement, or like a nested if statement, where this essentially, from line, if you just go up a little bit then, from line 17 to 28, it just says, do we have lots of red? If so, take it away, give me some green. Have we got maximum green? If so, take it away, give me some blue. And then if you've got max blue, take it away, give me some red. So it just cycles and shifts between these 3 different channels, and that is what gives you that rainbow sort of color changing effect. You should copy and paste that if statement and put it everywhere. I use it all the time. It's a really, really useful, just for making cool sort of visual things happen. And the variable that you're looking at there, called C speed, is the speed at which it changes. So how fast it shifts between red, green, and blue. So if that number, right now it's 0.01, because bear in mind, it only has to get from 0 to 1 to become full. So if you use the number 1, it will just instantly be full. You don't want to do that, so make it a small number, but the larger that you make that number, maybe like 0.8, you'll get very, very quickly. In fact, let's just change it and see what we can do with it. If we put 0.1, let's make it 10 times faster. That's nice. So basically, yeah, you are just seeing a greater variance of colours sort of happening quicker. But you will also miss out on some of the more subtle shades between the red, green, and blue spectrum.
A bit like that. So like the
See there, you've got much more of a gradient.
About the names of the colours, but rather,
Yeah,
I know the names of the main colours.
It takes longer for green to become blue, and therefore you've got the spectrum of like cyan and turquoise and teal and all that stuff. Cerise.
I've never heard of that.
Cerise, I think it's green. It's like it definitely is, because somebody on the Fuze Arena, which you should totally check out at the end of this video, I will mention it again. They were talking about cerise. It's like a nice sort of fancy mint green color. So there you go. Hopefully you can now use this project, go and make your own awesome bouncing ball program, or make a version of Pong or something like that, and go on to fuzearena.com or .co.uk. I keep forgetting now. If you just just search Fuze Arena, you will find us. It is our growing, ever faster growing community website where more and more people are now sharing their awesome projects. And you can make friends on there, download what they're doing. People are making full games with Fuze now, and it's so exciting. In fact, actually, on that note, Ben and I will be doing a showcase video very soon where we're going to look at a few of the more awesome and sort of complete projects that people have shared on Fuze Arena. There is some really, really cool stuff to get to. So if you want your programs and ideas shared on these videos and showcased, then by all means, share them on your Switch, get on the Fuze Arena. You can always send me a message or one of the Fuze team a message and just let us know that you've got this project. We'd love to take a look. If you've got anything that you think me and Ben would have a laugh using, or like a silly quiz or anything like that, we would love to try them out live on camera and just give you our reactions. I think that would be a really good laugh.
Yeah, that sounds like fun.
So hopefully you feel more comfortable with the screen and you can go about using it in your own projects. We will be going more into detail about this in future, but I think that about covers everything. Ben, have we missed anything on this?
Don't believe so.
I think we're all good. Right. Okay. So until next time, I have been Dave.
And I've been Ben.
And thank you so much for watching, and take it easy.